Now that you've learned how to create conditional statements, let's learn how to use them to control the flow of our programs. Now, when I say control the flow of our programs, from this point, or from all the previous learning that we've done, for the most part, everything has been pretty sequential. You don't really skip over any lines, and the only exception is functions. You kind of skip over them, but you're typically called, and so we go back and we run them. In this case, with the conditional statements, there's a possibility that we can maybe skipping over some lines or changing the branching of our behavior and not necessarily so sequential. So we're going to talk about conditional statements and how we use them in Python. This is done using the if, the elif, and the else statements. So let's go over what each of those statements are and how we use them. First up is the if statement. Let's think of a scenario here. What if we wanted to check if a number was divisible by 2? And if so, then we wanted to print that number out. Let's diagram this out. So here we have a diagram. We're flowing, our control flow here is through the arrows, and we have a situation. Is A even? Well, if the answer to that is yes, then we're going to print out A is even. And we're going to go back to our execution and then continue on. Now, if A is not even, then we're just going to go and move on. So to summarize, check to see if A is even. If it is, then print out the message. Let's see how we do this. This can actually be translated into an if statement. And I'm going to write this out in pseudocode, which looks very similar to Python. If A is even, then print A is even. Let's translate this even further into a Python function. So we've got a function here that says check evenness, and we're passing in a parameter A. Now we check to see if A is even. So if A is evenly divisible by 2, meaning there's no remainder, then we can print out if it's even. To check this out, we're going to go over the numbers 1 through 10 and check its evenness for each of those. And we can see 2, 4, 6, 8, 10 are all even. So this is how you do that. You do an if statement and then your conditional. And if that conditional is true, then what gets executed underneath that if statement is printed out. So we have an indentation of a second level here. Now, because it's inside of a function, it is 2 levels of indentation. If this was not inside of a function, it would just be a single level of indentation. We can actually chain multiple if statements together, and they're actually done sequentially, meaning that they're both evaluated. Let's go back up to our diagram here. When we do another if statement, it's as if we created a whole new another diagram for this and ran this executed and then placed it right here. So we're going to check if A is even and then check if A is positive, and we move on. So let's go and see how we implement that in Python. And this is how you would do that. So we set A equal to 0. And then if A is greater than 0, we're going to print A as positive. And then if A is divisible by 2, we're going to print out A is even. And because A is both 10 is both positive and it is even, then both of these statements are going to be printed out. Now let's talk about the else statement. The else statement is a way where we can add more branching or configuration here. So let's think and continue with our scenario here. What if we wanted to know if the number was even or it was odd? Let's diagram that out. So we're going to flow through here. If A is even, then yes, it is. Let's print that it's even. If no, it is not, then print A is odd. Okay, let's move on. Again, let's translate this into pseudocode using the else statement. So if A is even, then print A is even. Else, print A is odd. We can then additionally translate this into Python using the else statement there. So we've got our check evenness function here, passing in an A parameter, and we do our check for if it's even, and if it's not, then we assume that it's odd. And so here we go. Each of the numbers 1 through 10, we have odd, even, all the way through. just like that. Now, let's talk about the else if statement. Continuing on with our scenario, what if we wanted to check if a was divisible by 2 or 3? Let's check that out. So here we have a control flow. Is a divisible by 2? If it is, then yes, we want to print out 2 divides a. And then if a is divisible by 3, and yes, we want to print 3 divides a. I've got a little typo error here. I'll have to fix that. But 3 divides a, and in this type of case. Now, if both of those conditions are not true, then let's set our else statement to be print 2 and 3 don't divide a. So we have a condition here. Is this true? Yes or no. If it is, then print out this statement. Else, if this is true, then print this out. Else, print this. Let's translate that and look at that in pseudocode. So translating this in pseudocode, we're going to use else if. So if a is divisible by 2, then print 2 divides a. Else if a is divisible by 3, print 3 divides a. Then finally, else print 2 and 3 don't divide a. We can translate this easily in the Python, but you notice it doesn't use else if. Else if in Python is just elif. So we've got our function, and we've changed it up here. Check divisible by 2 and 3, passing in an a parameter. We check if a is divisible by 2, meaning that 2 division in here with a remainder of 0, then we say 2 divides a. Then if a divides by 3, or is divisible by 3, then we print that in there. Otherwise, we say that the value is not divisible by 2 or 3. So we're going to iterate through 10, through 1 and 10 again, and do this. So a is not divisible by 2 or 3, which 1, that's for sure. But 2 is divisible by a, and 3 is divisible by a when it's equal to 3. 2 is divisible by a if a is equal to 4, and so forth. And we can see that this is the way that it's working, and it's working the way that we would expect. Let's talk about how the order matters. So when we're chaining conditionals here, you need to be careful about how you order them. Let's go back to our scenario. What if we wanted to check if a number is divisible by 2 or 3 or both of them? Let's draft this up into our diagram. Let's check. If a is divisible by 2, well, yes, it is. Then let's print out 2 divides a. If a is divisible by 3, then let's print out 3 divides a. And then finally, if a is divisible by 2 and 3, then print out 2 and 3 divides a. Now let's follow this path here. If it's divisible by 2, we're going to follow this path. If it's not, then we're going to go down and follow this path, which should say 3, but it doesn't, and I'll fix that for you. But it was going to follow this path. Now, let's go one more time. Is a divisible by 2 and 3? Well, then yes. If it's both divisible by 2 and 3, then let's go through that. Let's run this example and see what happens. Here we have this check divisible by 2 and 3. We check to see if it's divisible by 2. We check to see if it's divisible by 3. And then we check to see if it's divisible by 2 and 3. And we do this. Then finally, we check. Then if it's not, then we print this out. Now let's go over this range, and let's look at an interesting thing. 2 divides a when a is 6. But that doesn't make sense. 6 is both divisible by 2 and 3. Why didn't it do that? Well, that's because of the ordering. Because we do sequential ordering for our chain when we chain our if statements. Our a here is 2, or is evenly divisible by 2. That means it's going to follow this branch and be done with the rest of these statements. Once it executes this and it's true, it's no longer going to execute any more of these statements. It's done, and it's going to move on. And so we need to be careful about how we rearrange this. So let's rearrange our diagram here. So is a divisible by 2 and 3? If it is, then we print out 2 and 3 divides a. Then let's check to see if a is divisible by 3. If it is, then print 3 divides A. Then finally, if A is divisible by 2, then print 2 divides A. And finally, if none of that works, we're going to print 2 and A don't divide A. Or 2 and 3 do not divide A. So again, path is the way that you take. The path is the way that it's take for the conditional. In this case, when 2 and 3 are divisible, then it's going to follow this path. And if only 3 is divisible, then it's going to follow this path. And then finally, if only 2 is divisible, then it's going to follow this path. Let's translate this back into Python code. Essentially, we've rearranged our previous function, and now the first statement is if 2 and 3 are divisible into A, then we print that out. And then we have 3 next up, and then 2, and then finally, everything else, it's not divisible by A. And we can see 2 and 3 divides A down here. And that's the proper way and the way that we would expect it to be. So note, when you create your conditional statements, you should always put your most restrictive conditional at the top of your if statement, and then work your way down to the least restrictive. So what do I mean by that? Well, look at this. If it's divisible by 2 and 3, and we look at our set here between 1 and 10, only 6 will be accepted by that conditional. That means it's the most restrictive. It has the fewest items that it's going to be accepting. Then let's move to 3. Well, when we look at our set of numbers between 1 and 10, only 3 of those numbers are divisible by 3. And that means it's the next most restrictive. Then finally, divisible by 2 is going to be 2, 4, 6, 8, and 10. And that means that is the least restrictive. It's going to be accepting the most. So you want to drill your down and be the most restrictive first, and then get your least restrictive. Because if we swapped these, then if it was divisible by 2, then we would never see these other 2 branches that are in there. And so now we've talked about the controlling our flow with conditional statements, and pretty much everything is just like a path for you. And you have to decide how that path is now going to go and kind of figure that out. This is where things really do become more like a puzzle. So I highly recommend that you write out and diagram your if, else and else statements so that you can really understand what it is that you're trying to do. And always remember to make sure that you have the most restrictive conditional at the top of your if statements, and then work your way down to the least restrictive ones. In our next video, we're going to do some in-class assignments on how to work with these conditional statements.